Hi, I'm Timothy Brusella, and today I want to do an example involving future value of ordinary annuities. Here's the problem. In order to accumulate money for a down payment on a house, a couple deposits $756 per month into an account paying 3% compounded monthly. If payments are made at the end of each period, how much money will be in the account in 4 years' time? So they're saving money. Notice they're making the payments. They're making periodic payments, $756 periodically every month, and they're making them at the end. Periodic payments made at the end of a period means that the account they're contributing to can be classified as an ordinary annuity. And they're saving for a future amount. The lump sum occurs in the future. The account starts off with the balance of 0, but it grows in 4 years' time. That's why we're using the future value formula. The future value formula, S equals R times 1 plus I to the n minus 1 all over I. S is what we're looking for, that sum amount. We don't know what's going to be in that account in 4 years. R is the amount of the periodic payment. They're making periodic payments of $756 into the account. At the end of every month, they're putting in $756. The I value. I is not just the 3%. You take 3% and you split it up over every month in the year, or in a year. So they're splitting the 3% up over 12 months. So you take the 3% and divide it by 12, and that terminates nicely to a 0.0025. What about N? N is the total number of payments they make into this account. They're making it monthly payments for 4 years. 4 times 12. They make 4 payments a year for they make 12 payments a year for 4 years, so that's 48 total payments. So plugging the numbers into the formula, let me move my paper up a little. 1 plus I can do that in my head. That's just 1.0025 to the 48 minus 1 divided by 0.0025. Punching this into our calculator, and let's see if we can see this calculator. Give me a moment. Let me make it a little brighter for you. That's not too bright, is it? Let's see. No, I'm not going to get it. The calculator's not going to show up, so it's just this lighting in this room is just not good enough. So I'll just tell you what you should be getting. We should be that couple should have saved up $38,503, and they want it rounded to the nearest cents, so 99 cents over the 4-year time period. Once again, it's hard to see that display. I entered in the numerator of the fraction, hit equals, then I divided it by the denominator, dividing it by the 0.0025, and then I multiplied by the 756. They should have a nice amount. This couple should have a nice amount saved up for the house payment. I guess the natural question is, why don't they just buy the house now and be paying the $756 a month that's a house payment? I don't know that, so I don't know what their story is or why they're waiting. I guess it doesn't matter, but let me box in that final answer. Okay, once again, this is Timothy Priscilla, just working an example involving the future value of an ordinary annuity. Bye.